Lighthouse Scientific Education presents a lecture in the Measurement and Number series. The topic, Scientific Notation. Material in this lecture relies on understanding of the previous lecture, Math for Chemistry. We will begin our discussion of scientific notation with an introduction. That leads into the construction of scientific notation with specific emphasis on the exponent. Next, we will cover the rules for conversions. First, from decimal form to scientific notation, and then from scientific notation into decimal form. We will look at how to do basic math with scientific notation values. And finally, there is a demonstration on how to input scientific notation into a calculator. Scientific notation and introduction. Scientific notation is a method for writing very large numbers, like 93 million miles, which is the distance to the sun, or very small numbers, like this one, which is the weight of a carbon atom in grams. All this without having to write so many zeros. The scientific notation of these two numbers are 9.3 times 10 to the 7 miles and 1.993 times 10 to the negative 23rd grams. Those are a bit easier to say. Considering the following number, 3,450,000. It is a large number with a fair amount of zeros. This number is currently written in what is called decimal form. We generally do not write the decimal point at the end of a whole number, but technically, it is there. We will make use of this dot later in the lecture. 3,450,000 can be converted into an equivalent or equal value using scientific notation, and that is 3.45 times 10 to the 6. Scientific notation is rewriting a large or small number as the product, that's multiplication, of two numbers. The digits 3, 4, and 5 are called the coefficient. The 10 is a base, and the 6 is an exponent. The base and the exponent are what give the number its size, really large or really small. We can look at that number in more detail. As mentioned, 3, 4, and 5 of this value make up the coefficient. The coefficient starts with a non-zero number and ends in a non-zero number unless the ending zero is actually a known value. That topic is discussed in more detail in the significant figure lecture. For demonstration purposes, we will say the coefficient ends in a non-zero number. The coefficient is always written single number, dot, and then the rest of the digits. Here we're using X to represent numbers or digits. The decimal point can also be called a dot or just a point. In fact, all three terms are used regularly. Examples include 1.23, 2.34, and 4.002. Note that in each example, there is only one number in front of the decimal. The rest of the numbers come after the decimal. The zeros we saw in the original large number are left off because they are usually just placeholders and not known values. Again, that topic is discussed in the significant figure lecture. Scientific notation is never written, or is not supposed to be written, 0 dot number number or number number dot number. Examples 0.123 and 12.3 are both considered wrong ways of writing the coefficient. Now, these may be correct values, but they are not the correct way of writing the coefficient in scientific notation. The next term is a base, and that will be the value that we multiply or divide the coefficient by. We will look at that in more detail later. You will always be using 10 since our number system is base 10. The last term is the exponent, or the power. If it is a positive number, it states how many tens the coefficient should be multiplied by, and that will produce a large number. If it is negative number, it states how many tens the coefficient needs to be divided by. That will produce a small number. Since the exponent is positive in this number, it says multiply 6 tens by the coefficient. The exponent in greater detail. 3.45 times 10 to the 6 is equal to 3,450,000. So 10 raised to the 6th power must mean 10 times 10 times 10 times 10 times 10 times 10. 6 tens multiplied together is 1 million. The exponent form 10 to the 6 is more compact and easier to follow. We can contrast that with 3.45 times 10 to the minus 6, which is equal to 0.0000345. That's 5 zeros. This equation is only possible if 10 to the minus 6 is equal to 1/10 times 1/10 times 1/10 times 1/10 times 1/10 times 1/10. Doing the math gives us 1/10 multiplied 6 times. And we just saw that multiplying 10 times itself 6 times is equal to 10 to the 6th. Thus, 10 to the minus 6 is equal to 1/10 to the positive 6, or 1/1,000,000. The negative exponent creates a very small number. What we gather from these two examples is that the 10 raised to a positive exponent times the coefficient creates a large value, and 10 raised to the negative exponent times the coefficient creates a small value. Finally, an important rule of exponents can be shown here, and that is 10 to the minus 6 is the same as 1/10 to the positive 6. The negative does not make the coefficient negative. It means 1/10 to the positive value of the exponent. We will keep these two equations as references as we discuss the rules from going from decimal to scientific notation. The first rule, starting from a decimal number. Move the decimal point, digit by digit, to the right for numbers that are less than 1, or to the left for numbers that are larger than 10, until the decimal point is after the first non-zero number. And we're going to leave off the leading and trailing zeros. There are quite a few parts to this rule, but it will become clear as we demonstrate the process. But first, a word about zeros. For most really large or really small numbers, the zeros are not known values. They are placeholders necessary to write the number. Trailing zeros come before the decimal point. They come after the last non-zero digit. In this case, it's a 5. Leading zeros come after the decimal, and they come before the first non-zero digit. Rule 2. Count how many places, that's how many digits, that you moved the decimal point. This is going to be the exponent number. Rule 3. Add a negative sign, or a minus sign, to the exponent if you move the decimal point to the right, not to the left. Moving the decimal to the right means that the number in decimal form is smaller than the coefficient when written in scientific notation. For 3.45 times 10 to the negative 6, the coefficient 3.45 is larger than the decimal version of the number. Shall we try a few problems? See these rules in action? All right. The mass of the largest dinosaur ever, Argentinosaurus, 730,000 kilograms. Begin by writing out that number. Even though it is generally not written, we know that there is a decimal after the last zero. the last 0 is in the ones column. Consulting Rule 1, we see that we should move the decimal point to the left since the number is larger than 10. We need to move it until the decimal point is after the first non-zero number. That's between the 7 and 3. Okay. 1, 2, 3, 4, 5. That's 5 spots. The decimal goes right behind the 7, and our coefficient is 7.3. We are leaving off the trailing zeros. Consulting Rule 2, we see that we need to count the places we moved the decimal, and we did that. It was 5. Our base is 10, and our exponent is 5. And finally, as stated in Rule 3, we check to see if we need a negative sign on our exponent. Did we move the decimal to the right? No, we moved it to the left. So, no minus sign. Therefore, 730,000 is written in scientific notation as 7.3 times 10 to the 5th. Here is a number with a lot of leading zeros. It is the diameter of a red blood cell. It is 0.00000076 meters. We write the number out, and we see that the decimal is quite a ways from the non-zero 76. Consulting Rule 1, we see that we should move the decimal point to the right since the number is less than 1. We need to move it until the decimal point is after the first non-zero number. That's between the 7 and the 6. Okay? 1, 2, 3, 4, 5, 6. The decimal goes after the 7, and our coefficient is 7.6. Rule 2 tells us to count the steps we took, and we did that. It was 6. Our base is 10. Our exponent is 6. And finally, we check to see if we need a negative sign on our exponent. Did we move the decimal to the right? Yes, we did. So we will need to add a negative sign before the 6. Therefore, 0.000076 meters is equal to 7.6 times 10 to the minus 6. Following the rules, you can convert very large and very small numbers into scientific notation. What if you want to go in the reverse direction? That is, what if we had a value in scientific notation and wanted to convert that to decimal form? That process is really a reverse of the process of getting into scientific notation. And it can be boiled down to 2 paths that center on the sign of the exponent. We will use 2 examples to highlight the paths. Path 1. If the exponent is positive, that'll be for a very large number like this one, move the decimal point in the coefficient to the right as many spots as the exponent, even though there may not currently be any numbers in those places. Then add zeros after the last digit until the decimal is reached. Starting with the coefficient, 4.8. Note that the exponent is a positive 4, so we move the decimal over 4 places to the right. 1, 2, 3, 4. The decimal moves to its new place. And now add zeros after the last digit until the decimal point. 3 zeros and a value of 48,000. And that decimal point can be removed. The second path is when the exponent is negative. That'll be for small numbers. Here we move the decimal point in the coefficient to the left as many spots as the exponent. Then we add zeros before the leading digit until the decimal is reached. Applying Rule 2 to 6.3 times 10 to the negative 5th, starting with the coefficient 6.3, note that the exponent is negative 5, so we will remove 5 places to the left. Ready? 1, 2, 3, 4, 5. The decimal point will now move from here to here. We need to add zeros before the leading 6 until we get to the decimal. 0.000063. An extra zero, like the one here, is usually put in front of the decimal so that the dot is not out there in front all by itself. It is not required, but it helps avoid confusion regarding the dot. Basically, what we have seen is that moving between scientific notation and decimal is about knowing which direction to move the decimal point and by how many spots or places. A good practice to check if you've made the conversion correctly is to ask if the decimal in scientific notation are both either big numbers or both small numbers. They cannot be one of each. Doing math with numbers in scientific notation is similar to that of numbers in the decimal form, as long as we remember that scientific notation is itself a multiplication of two numbers. We will look at the operations of multiplication and division and then take on adding and subtraction. Multiplication first. How can we multiply 9.2 times 10 to the fourth and 6.7 times 10 to the minus third? The easiest way is to break scientific notation into parts. We start by 1, multiplying the coefficients. Then add the values of the exponent, because when multiplying exponents of the same base, you add the exponents. Return the new exponent value to the base, then combine the new coefficient and the base with exponent. Adjust to proper form, that is proper scientific notation. There will still be issues with rounding and significant figures, but we will get into that in the significant figure lecture. We can apply these steps to the problem at the top of the page. Step 1. Multiply coefficients. 9.2 times 6.7 equals 61.64. Add the values of the exponents. 4 plus negative 3, and that is 4 minus 3, which is equal to 1. Return the 1 to the base, 10. Combine the new coefficient and exponent, 61.64 times 10 to the power of 1. The coefficient is not in proper form. We need to move the decimal to the right one spot, and that means add one more to the exponent. That gives us 6.164 times 10 to the second power. Division is very similar to multiplication. First, divide the coefficients. Then, subtract the value of the second exponent, that is the bottom or denominator if written in a fraction, from the value of the first, which is the top or numerator if written in a fraction. That's because when we divide exponents of the same base, we subtract the exponents. Return the value of the new exponent to base, and finally combine coefficient and exponent and adjust to proper scientific notation form. Using the equation above, step 1, divide coefficients. 9.2 divided by 6.7, and that's going to equal 1.373. Step 2, subtract value of second exponent from value of first. The first exponent is 4, and the second is negative 3. 4 minus negative 3 is 4 plus 3, which is 7. If you need to, review your addition and subtraction of negative numbers. Return the 7 to its base. Combine coefficient and exponent, 1.373 times 10 to the 7th. Since the coefficient is in proper form, we're done. There is no easy way to add and subtract numbers in scientific notation. The best way requires moving between decimals and exponential form. Here is a 4-step process that outlines the practice. It works for both subtraction and addition. Step 1, convert to decimal form. Step 2, line up the decimal points. Do this by putting the first number on top of the second number instead of side by side. 3, do the math. And then step 4, convert back into scientific notation and round if necessary. Using the addition problem at the top of the page is our first example. Step 1, convert 7.4 times 10 to the minus 4 and 3.4 times 10 to the minus 2 to decimal form. For 7.4 times 10 to the minus 4, we move 4 places to the left, giving 0.00074. For 3.4 times 10 to the minus 2, we move 2 places to the left, giving 0.034. Step 2, line up the decimal point. This is so we are adding the same place in each number. That is, the tenths add to the tenths, the hundredths add together, and so on and so on. Step 3, doing the math gives us a value of 0.03474. And the last step is to convert into scientific notation. We want the decimal point between the 3 and 4. Well, if we move the decimal 2 places to the right, we have 3.474 times 10 to the negative 2. Subtraction is done the same way. We can start at the step 2, line up the decimals, note the subtraction sign. Doing the math will give us a value of negative 0.03326. And the last step is to convert back into scientific notation and round, again holding off on that. We want the decimal to be between the 3's. We move the decimal 2 places to the right, and our final answer is negative 3.326 times 10 to the minus 2. For our final topic, we're going to cover the use of scientific notation with a calculator. Here are a couple of numbers that we can use as practice examples. It should be noted that calculators vary tremendously on how they input numbers, so the procedure we'll cover here may not work exactly the same on your calculator. It is, however, a good procedure. And let's review the procedure first. To begin, enter the coefficient with the decimal point. Press the EXP or EE key. Almost all calculators will have a button that selects 10 as its base. Find it on yours. Enter the value of the exponent. Don't forget the negative sign if there is one. Note that the subtraction key is not the negative sign. Usually it is a plus, minus, or negative key. Some calculators require you to enter the negative before the exponent. Some let you change the sign of the exponent after you add it. And then press enter or equal. Alright, shall we try entering 7.4 times 10 to the minus 4? We'll begin by entering the coefficient. 7.4. Press the EXP button. Enter the value of 4. Hit the plus negative sign and return equals. Clear. Suppose we want to enter 3.4 times 10 to the 6. Enter the coefficient 3.4. Press EXP. Enter the value of the exponent, 6. We don't need to add a negative sign, so just hit equals. 3,400,000. Doing math on a calculator using scientific notation is just like using decimal numbers, except we're entering the scientific notation values. We will do 2 problems. One will be addition and the other multiplication. The first one is adding 7.4 times 10 to the minus 4 to 3.4 times 10 to the minus 2. We've already done this problem, so we can double check our answer. We begin by inputting the values. 7.4. Find that EXPEE button. Where is that thing? Enter a 4. And then a negative sign to get negative 4. Hit the plus sign. Enter 3.4 EXP 2 negative sign. Hit equal or enters, and we get 0.0334774, which we can convert into scientific notation by sliding the decimal 2 points to the right, giving 3.47 times 10 to the minus 2, which is the same answer we found in the previous problem. The second problem, 9.2 times 10 to the fourth multiplied by 6.7 times 10 to the minus 3, should also look familiar. We begin by inputting the first value, 9.2 EXP 4. Hit the multiplication sign. Second value, 6.7 EXP 3. Minus sign to get negative 3. Hit enter equals 616.4, which we can convert to scientific notation by sliding the decimal 2 places to the left, giving 6.164 times 10 to the second. Scientific notation makes writing very large or very small numbers easier. Scientific notation is made up of 3 parts, deduced from the decimal version of the number: coefficient, base, and exponent. We saw that the exponent 6 says to multiply 10 6 times, and that's 1 million. And the exponent minus 6, or negative 6, says to multiply 1 over 10 6 times, which is 1 over 10 to the 6, or 1 over a million. The rules for converting decimal to scientific notation are: 1. Move the decimal point to the right for numbers less than 1, or to the left for numbers greater than 10, until the decimal point is after the first non-zero number. 2. Count how many places or digits that you move the decimal point. This is the exponent number. 3. Add a negative sign to the exponent if you move the decimal to the right. Scientific notation, the decimal. If the exponent is positive, move the decimal point to the right as many spots as the exponent. Add zeros after the last digit until the decimal is reached. If the exponent is negative, move the decimal point to the left as many spots as the exponent. Add zeros before the leading digit until the decimal is reached. And finally, math, using scientific notation: multiplication and division, multiply or divide coefficients. For multiplication, add exponents. For division, subtract them. Convert to decimal form. Addition and subtraction, these take more work. Convert to decimal form, align the decimal point, and do the math. And that concludes the lecture on scientific notation. Remember to practice what you've seen to truly build understanding. Develop a good working relationship with your calculator.